bringing Martian samples back to Earth, where the full power of our terrestrial laboratories could be applied to unlocking the story of the red planet's geology, climate, and especially its potential for life, either in the past or even today. After the Mars 2020 rover has placed its collected samples on the Martian surface, a second follow-on mission would land nearby, deploy a small rover to fetch the samples, and bring them back to the lander, where they would be loaded into a container and placed atop a small rocket. The rocket would then lift off, carrying the samples up into Mars orbit.
You can do a lot on the surface of Mars with the rovers, but it's not comparable to what you can do with a fully equipped lab on Earth. On Earth, we've got geologists, we've got electron microscopes, we've got biological experiments, we've got all the technology that's been developed over the space race and even before that. So we can do a whole wealth of investigations, looking for fossils, looking for signs of previous life on Mars, better understanding of the geological processes that have shaped the surface of Mars, which just aren't possible within the power, size constraints that you have on a rover or a spacecraft.
The Mars Science Laboratory Curiosity mission were to specifically seek the signs of life and then sample materials and prepare a cache that could be returned to Earth by a future mission. To prepare samples, drill them out of a rock, seal them in a tube so that a future mission could go and bring them up. We call that caching.
So it is
It will have a robot arm on the front of the rover, and that, along with the vision system, will have to detect sample tubes left on the surface of Mars by the NASA 2020 rover. It will have to detect them, autonomously use the robot arm to pick them up, store them on the rover, and then the rover has to drive back to the lander and deposit those sample tubes there. So, because of the distance between Earth and Mars and the complexity in communicating with the rover, it needs to do that without human intervention from ground.
Just a bit, and then I've cut it down quite significantly.
So you can see the arm, the robot arm, it's moving over to collect the tube, and you can see one of the wheels there. You can see these coloured markers where the algorithms actually correctly identified one of the sample tubes to the sort of environment that will be working in on the surface of Mars.
One of the key things that we have to look out for is that we're going to be trying to find these tubes at different times during the day. And that means that there will be potentially different lighting conditions, different shadow conditions. If we're behind one rock at one time of the day, the shadow could completely cover our tube. However, in other times in the day, we might be in brightness or with the tube casting its own very large shadow behind it.
And so we got this, which is our dummy RSTA, which is a whiteboard marker.
Yeah.
This is our sample tube dummy, which is a whiteboard marker. I think gold dust is a good way of describing it. They would be so valuable in terms of the science return. We'll learn so much from them, about the history of Mars, the geological history, perhaps the biological history, the chemical history. Learning about other planets can also inform us about how our whole solar system formed, including our own planet. So there's a wealth of knowledge. I believe people are still getting papers and scientific discoveries out of the lunar samples, 50 years on. So if you imagine what we'll get out of Martian samples, the mind boggles really.